Hi everyone, welcome to YourPedia. Friends, very happy Independence Day to all of you. Friends, as we are expecting that today official notification should be released from Andhra Pradesh website, but there is no official notification comes out, and internal news is that it will be released next month around 15th or 16th of September. So that means friends, you have sufficient time, because after the notification they will give you some 2 months extra for the exam. So that means now you have a 3 months, you can consider you have a 3 months. So if you didn't start your preparations till now, then you have a 3 months and you can prepare all your syllabus in during these 3 months. And friends, so we have launched already all the modules and we have covered entire syllabus as per the mentions. So whatever the topics are mentioned in the syllabus, we have covered all the topics. So friends, now if you want to prepare, if you want to do preparations, so you can go through all the recording sessions that will be available. If you want to know anything regarding the module, you can contact us, you can discuss, you can call in the institute. Okay, so friends, now today I am going to discuss some questions related to your factory inspector post, friends. So one topic is mentioned, that is the industrial waste and their disposal, their treatment. So I am going to tell you some different questions related to this domain, industrial effluents and their treatment, right? So let's start the question one by one. Now friends, first question we have high TDS in the textile wastewater is mainly due to the extensive use of. So question is saying that in the textile wastewater, you will find this high TDS. So high TDS in the textile wastewater is mainly due to the extensive use of. So what is the reason behind that? That in the textile wastewater, high concentration of TDS is there. So option A, sodium chloride, sodium sulfate, calcium carbonate only, activated carbon, methane. So the answer is sodium chloride and sodium sulfate. So these sodium chloride and sodium sulfates, basically these large quantity of salts generally we use during the dyeing to improve the dye fixations. So friends, basically large quantity of salts are generally used during the dyeing to improve the dye fixations, and unused salts enters the wastewater and they increase the TDS and conductivity. If TDS is going to be increased, then conductivity is also going to be increased. Electrical conductivity, or you can say the specific conductance of the water, that mainly is due to the presence of these ions, right? And conventional biological treatment cannot effectively remove these dissolved salts, because these biological treatment are used for the removal of the dissolved organic particles. And if you want to remove these dissolved salts, so we have a different technology, we have a different methods. Like one of the method, you can use the reverse osmosis, ultrafiltration technique, nanofiltration technique you have. So we have a different techniques to remove this salts concentrations from the water. So high TDS in textile wastewater, the reason mainly due to the extensive use of sodium chloride and sodium sulfate, and these sodium chloride, sodium sulfates are used during the dyeing to improve the dye fixations. So here we add some salts during the dyeing. We add some salts like sodium chloride, sodium sulfate. So second point is that these salts, why we are adding these salts, that increase the ionic strength of the dye bath. It improves the dye solubility and penetration, and it enhances the dye fixations on the fibers. So these are the basic reasons why we are adding these salts in textiles. So after the dyeing, third step is after the dyeing, a large portion of added salts remains unused in the bath. So that unused salts water, that is the wastewater basically. So these unused salts enters the wastewater. So that's why the TDS comes out to be higher in your textile industry wastewater. So wastewater characteristics, if you talk about, then it will be like it will consist high amount of salts, that are the sodium chloride, sodium sulfate. So that will result in high TDS and high conductivity, right? Now next question we have, friends, which process is particularly useful for removing the persistent color from the textile wastewater? Now the question is saying which process is particularly useful for removing the persistent color that cannot be easily removed. So persistent color you want to remove from the textile wastewater. So which methods are basically used? So friends, this screening, grit removal, and Plain sedimentation we have discussed in the classes, and if I tell you that screening process generally we use for the removal of the heavy suspended solids, and grit chamber, we have a grit chamber for the removal of the inorganic suspended particles or for the removal of the grit particles. So if we want to remove the grit particles, inorganic suspended particles, so we have a grit chamber. So these grit chambers basically remove the grit particles. And in the plain sedimentation generally we use remove the organic suspended particles. It is designed for the removal of organic suspended particles. So advanced oxidation process you can use. Advanced oxidation process in this case you can use for the removing of color substances, or you can say color causing substances, the substances which are present in the wastewater that causes some color, that induce some color in the water sample. So for removal of those substances you can go with advanced oxidation process. And in this advanced oxidation process basically what happens, in advanced oxidation process this generate highly reactive radicals that are capable of destroying the complex dye molecules. So this advanced oxidation process if we talk about, so here we can use some agents, like you can say you can use ultraviolet rays, you can use ozone, right? So when you add ozone or ultraviolet, or you can say hydrogen peroxide H2O2, or you can say phantom oxidations, so when you use this when you these oxidation agents, oxidizing agents, so what happens, they basically generate highly reactive radicals. So these highly reactive radicals generated, and these highly reactive radicals going to destroy, they destroy complex dye molecules. They destroy complex dye molecules. So that's why they are particularly useful for the refractory colored compounds. So just remember simple point. Remember the key point is that for persistent for removal of persistent color causing substances, so advanced oxidation process is used. So here if you see this diagram, so the problem is that textile wastewater contains complex dye molecules that causes the persistent color. So here a process that can break down complex dye molecules and destroy the color. So our aim is to remove that. So how this advanced oxidation works? So when advanced oxidation work, it will generate some reactive hydroxyl radicals, and when these radicals generated in the water sample, so it is going to break down complex dye molecules. So when it break down these complex dye molecules, so by doing this, the substances which are responsible for the color, they are removed, right? So examples of advanced oxidation process like ozone, ultraviolet, phantom oxidations, you can use that, right? And the results, if you talk about, then color removed, dyes destroyed, suitable for refractory compounds, suitable for refractory compounds. Now question number 3, which unit is important before the biological treatment of highly variable textile wastewater? Highly variable textile wastewater. So which unit is important before this biological treatment? So we have discussed in the classes when we talk about the preliminary stages, primary treatment, secondary treatment, tertiary treatment, friends. So we have discussed that after the preliminary treatment, wastewater enters in the equalization chamber. So the purpose of equalization chamber, we know that to prevent any type of fluctuations, any type of variations, right, in the flow properties, or you can say to avoid the shock loading. So basically our wastewater, if our wastewater or you can say the wastewater that is coming from any industry, so it sometimes it is high value, sometimes it is of lesser value, some variation in the discharge if there. So for removing this for avoiding this variations, for avoiding this fluctuations, what we do, we have designed some equalization chamber, equalization tank we have designed. So by using this equalization chamber, after that water enters into the primary sedimentation tank. So from this equalization chamber, when water enters in this primary sedimentation tank, so at the constant rate water starts moving into the primary sedimentation tank. So the extra amount of water it will store, and when water is coming very lesser amount, so this surplus water that is that stored earlier in this equalization chamber, so this chamber will release that surplus water, and it will release, so that constant supply from the equalization chamber to the primary sedimentation tank has occurred. So equalization chamber, equalization tank reduces variation in flow, pH, pollutant concentration. So very important point, friends. The question is saying which unit is important before biological treatment. What is the reason why we are providing this equalization tank? Because we know in this primary sedimentation tank, when sludge formation is there, and that sludge consists high amount of organic matter, and this decomposition is carried out anaerobically, and end product of anaerobically we get methane biomass, we get methane. So what happens when anaerobic decomposition takes place? So two type of microorganism generally comes out. You can say two types of microorganisms are there which decompose the organic matter, and we discussed in the classes that we have acid formers, we have a methane formers. So these methane formers, friends, these are the microorganisms that works in the narrow pH range of 6.5 to 7.5. Ultimately, when organic matter decomposed anaerobically, it will convert into methane. So until methane you can say when decomposition will be completed, so it will be indicated that methane is released. When methane is not being released, that means decomposition is incomplete. And this conversion of organic matter into the methane, so first it will convert into acid alcohol, that is done by the acid formers, and after that this acid alcohol further converted into methane, that is done by the methane formers. So basically at last product form is methane. So this methane formers plays a very crucial role in the decomposition, and they works in the narrow pH range 6.5 to 7.5. So that's why we have to maintain this pH during the digestion process. So that's why we want to avoid these fluctuations. We don't want any type of fluctuations in the primary sedimentation tank. If fluctuation is there, so then in that case pH can be rise or can be decreased. So equalization tank. So this equalization tank generally is used. Equalization reduces the variation in flow, pH, pollutant concentrations. It prevents the shock loading of downstream biological process. Mixing is normally provided to avoid the solid deposition. In the equalization tank, generally we provide the mixing, so that if we don't provide any type of mixing, so what happens, the solid starts get settling in the equalization tank, and we have not designed the equalization tank for the settlement of any type of solids. So that's why the mixing is generally adopted. So that's why mixing is generally adopted, friends. So here this is the type of equalization tank, and here continuously mixing is there, so that solids cannot be settled in the bottom, they remains in suspensions. So water coming from from this equalization tank enters into this primary sedimentation tank, you can say, for biological treatment. Benefits: it reduces the variation in flow, pH, pollutant concentration. It prevents the shock loading of downstream biological process. It ensures the stable and efficient biological treatment. It improves treatment performance and effluent quality. Mixing is normally provided to avoid the solids depositions. Now we have question number 4, that which membrane process can significantly reduces the TDS in treated textile effluent. So when question is saying that which membrane process can significantly reduce the TDS, and I discussed that we have a question number 1, and I told you right now that for the removal of the dissolved salts we have process like reverse osmosis, filtration, ultrafiltration technique, nanofiltration technique we have. So evaporations also we have a method, freezing also we have a method, electrodialysis also we have a method. So we have different methods for the removal of these salts, dissolved salts, right? So which membrane process can, and if question specifically ask about the membrane, so in the reverse osmosis we are using the semi-permeable membrane. So reverse osmosis, it is just opposite of reverse osmosis, it is just opposite of osmosis process. Osmosis process, we say that the movement of the water from higher concentration region to the lower concentration region. So the chamber in which the concentration of the water is higher, and the chamber in the concentration of water is very lesser. So the movement of this water is taking place from higher concentration region to lower concentration region, that is named as the osmosis process. But reverse osmosis, because we want to remove the salts, so we allow some pressure, we allow the movement of the water from lower concentration region to higher concentration region. So we have to give some energy to the water, so we apply some pressure. So that's a reverse osmosis process. And semi-permeable membrane we have that separate two chambers, and when water pass through this semi-permeable membranes, the solid starts getting retained, the dissolved solids starts getting retained over the semi-permeable membranes, and only water molecules passes through the semi-permeable membranes. right? So reverse osmosis, friends, the answer of this is reverse osmosis, right? A major problem associated with direct irrigation using highly saline textile effluent is. So question is this: the major problem associated with direct irrigation using highly saline textile effluent is. So that's why question is saying that if you use textile wastewater, indirectly irrigations for irrigation purpose, what will be the problem? And we know that a textile effluent consists high amount of salts, so it will increase soil salinity. The soil salinity will be increased. Repeated application of saline wastewater causes the accumulation of dissolved salts in the soil. This can decrease crop growth and alter the soil structure. So we have a term like sodium absorption ratio. It is going to be increased. So right, we have a term, but remember this only soil salinity. And if I write the term here, sodium absorption ratio, so we have a term, it will going to be increased, and that is not beneficial for the plants, for the crops. So it decrease crop growth and it alter the soil structure. Therefore salinity must be considered before land disposal or irrigation reuse, right? So we have a source of saline textile effluents. We have a source that consists sodium chloride, sodium sulfate, calcium chloride, magnesium sulfate. So when we use this saline water indirectly in irrigation for irrigation purpose, so what happens basically, the accumulation of these salts in the soil will be there. That means it will increase the soil salinity. So this toxic effect of specific ions, sodium chloride and this sodium chloride etc. can be toxic to the plants. So it will leads to the poor soil structure. It will reduce the infiltration and permeability and nutrient imbalance, that overall results in poor growth of the crops. The major heavy metals associated with tannery wastewater, friends, very important. Tannery, if we question ask about the tannery, and if question ask the major heavy metals, so mostly major heavy metals from the tannery, that answer will be chromium. This chromium source, especially basic chromium sulfate, and in the chromium source especially chromium sulfate. If question asked chromium sulfate, so this chromium source, especially basic chromium sulfates, are widely used in leather tanning. In leather tanning, residual chromium enters tannery wastewater, and this chromium containing streams are often segregated for recovery and treatment. So the major heavy metal, if question asked, the answer will be chromium. So use of chromium in the tannery, that basic chromium sulfate we generally use for tanning, and it stabilizes the collagen in hides and skins to produce the leather. So for the formation of leather, this chromium is being used, right? Sources of chromium in tannery wastewater like soaking, liming, baiting, pickling, tanning and washing. So these during these all the processes, the wastewater containing residual chromium. So the form of chromium in the wastewater, the chromium can be found in the wastewater like in trivalent chromium or as well as in hexavalent chromium, Cr6 positive, Cr3 positive. So friends, among these two, Cr6 positive is undesired form. It is undesired form. It is more toxic, carcinogenic, that means cancer causing. But Cr3 positive comparatively lesser toxic and lesser mobile. So it will be lesser mobile and lesser toxic, Cr3 positive. So these two forms of chromium will be found in water, and Cr3 positive, Cr6 positive, but Cr3 positive is comparatively lesser toxic. The typical concentration in the tannery wastewater, no need to remember this point. This is just extra points. Management of the chromium containing streams, like how will you manage? So segregation of chromium containing wastewater streams. First, recovery of the chromium. So this chromium can be recovered in the form of precipitate. It can be recovered from the wastewater, or you can say it can be removed from the wastewater in the form of precipitate. So precipitations as chromium hydroxides, electrochemical recovery, treatment, reduction of chromium 6 positive to chromium 3 positive if present, and precipitation filtration. Then this wastewater can be discharged on any you can say we have a disposal conditions, or you can say disposal options, like you can dispose this wastewater to any water body, surface water body, and you can dispose it over the land surface. You have, and this, when you are going to dispose this wastewater on any disposal options, so the parameters that are present in the wastewater should match with the standards that are prescribed by the CPCB. So just remember this point. Chromium can commonly be removed. This question again asked that chromium can be removed from ternary effluent in the form of precipitate. So chemical precipitations is going to be there. So in this, during this chemical precipitations, we can remove this chromium precipitate. So trivalent chromium can be precipitated as chromium hydroxide. So remember this trivalent chromium. This trivalent Cr3 positive trivalent chromium can be precipitated as chromium hydroxide by adjusting pH. The precipitated solids are subsequently removed by sedimentations, and these precipitates are removed by sedimentation, and further chromium recovery from segregate tanning liquid is also desirable. So here the process, but no need to remember, just remember the key point that how the chromium can be removed. So it can be removed in the form of precipitations. It can be removed in the form of precipitates. So for the removal of in the form of precipitates, so this chromium containing ternary effluent Cr3 positive in solutions. So we add some alkaline solutions, like you can add the sodium hydroxide, you can add the calcium hydroxide, lime you can add. So when you add this lime, so the reaction is going to take place. So this is the precipitation form, CrOS thrice positive, this is the precipitate forms, and after in the sedimentation, or you can say clarification, these precipitates are going to be settled at the bottom, right? What is the major source of high salinity in ternary wastewater? So in ternary wastewater also the source concentration is high, but what is the major source? You can, question is asking a major source of high salinity. The major source of high salinity is hide preservations using salts. So this is the major source. So that's why the ternary wastewater consists high amount of salts. Like sodium chloride is commonly used to preserve raw hides and skins. So if we want to preserve the hides and skins, so generally sodium chloride is used. Question can be framed: which solution is used in ternary industries for purpose to preserve the raw hides and skins? Sodium chloride is commonly used. Sodium chloride. Salt enters wastewater during the soaking and other operations. High salinity may adversely affect biological treatment and the land applications. Sodium sulfide is commonly used during the unhairing of hides. Again, question can be framed that for unhairing of the hides, which compound is generally used? Sodium sulfide. Sodium sulfide is commonly used during the unhairing of hides. Residual sulfide enters wastewater and can generate toxic hydrogen sulfide. Again, question can be framed: this sodium sulfide, if present, and if it is present in the wastewater, it can generate to toxic hydrogen sulfide under acidic conditions. Proper oxidation and segregations are therefore important. One more point, that acidification of sulfide, during the acidification of sulfide, as we discussed here, hydrogen sulfide released. So acidification of sulfide containing wastewater can release the H2S gas. Hydrogen sulfide is toxic, corrosive, and has a rotten egg pungent smell. Incompatible ternary streams should therefore be kept separate, right? So these all points are very important, friends. The principal highly polluted wastewater generated by a molasses based distilleries. The molasses based distilleries, question asked, the principal highly polluted wastewater. Now that is very important point, highly polluted, because we know from the distilleries two type of wastewater is there: spent wash and spent lees. So if question asked principal highly polluted, so we know high strength wastewater is spent wash. High strength wastewater is spent wash, around 15 to 20 liter spent wash, around 15 to 20 liter wastewater released during the manufacturing of 1 liter of alcohol generally. So the principal high polluted wastewater we have discussed all in detail in our classes, right? So the principal highly polluted wastewater generated by a molasses based distillery is the spent wash. Spent wash, other wastewater is spent lees, but here the highly polluted, question asked about the high strength wastewater, high polluted wastewater, so answer is spent wash. Distillery spent wash is a dark colored. So some characteristics of this spent wash water: it is the dark colored high strength wastewater produced after alcohol recovery. It contains very high organic loading, very again important point, and it requires intensive treatment before reuse or disposal. Spent wash contains large quantity of soluble and suspended organic matters. It consists large quantity of soluble and suspended organic matters, and because it consists organic matter, so its BOD and COD considerably high. Its BOD and COD are therefore much higher than those of ordinary domestic wastewater. So anaerobic treatment is commonly used initially. Initially here anaerobic treatment we generally preferred, because during this anaerobic treatment we know endpoint we are getting the biogas. We are getting the biogas during the anaerobic decomposition, and products are acetyl alcohol gases. In the gases we have a methane, and the methane having a high calorific value, so we can use it as a fuel. Spent wash contains complex colored compound including melanidin type material. These substances can resist conventional biological degradations. So here spent wash contains complex colored compound including this melanidin type material. So that's why what happens when we talk about anaerobic treatment, so before this anaerobic treatment we have to remove these substances, right? We have a different treatment method, so we can remove these all. Now question number 10 we have, friends, which treatment is particularly suitable as the first major biological step for the distillery spent wash. Again question is saying that which treatment is particularly suitable as the first major biological step. So initially biological decomposition is carried out. The decomposition either of aerobic and anaerobic. Initially we do the decomposition anaerobically. So initially we do the decomposition anaerobically. After that we go for aerobic treatment when very lower concentration of organic matter remains, higher concentration of organic matter is decomposed anaerobically. So which treatment is particularly suitable, and why we prefer this? Because I discussed here, I told you that we are getting methane. So answer is anaerobic digestion. High strength biodegradable waste water is well suited to anaerobic treatment. Anaerobic reactor reduces organic loading while producing the methane rich biogas. And this also reduces the aeration energy requirement, friends. Now anaerobic microorganisms convert organic matter to the methane and the carbon dioxide. Methane rich biogas can be utilized as a fuel, improving the energy efficiency of the treatment system. So every point is written here. Which reactor is commonly suitable for the high strength distillery wastewater? Now question is saying which reactor is commonly suitable for the high strength distillery wastewater. So for the treatment for high strength distillery wastewater, that means question is asking about the spent wash. So in that case which treatment method is mostly used? So generally we use the UASBR, upflow anaerobic sludge blanket reactor. So in the upflow anaerobic sludge blanket reactor we know the flow of the water takes place from the bottom to the top, and when water is flowing in the upward directions, so microorganisms are going to decompose the organic matter in the closed environment. Anaerobic decomposition is there. Upflow anaerobic sludge blanket reactor is there. So UASB is a high rate anaerobic reactor capable of handling high organic loads. So generally UASBR is preferred, that is capable of handling high organic loads. Granular anaerobic sludge convert biodegradable pollutant into the biogas, which producing relatively little excess sludge. So if you use granular anaerobic sludge, that convert the biodegradable pollutant into biogas while producing relatively little excess sludge. So this is all about your wastewater, distillery wastewater. So why UASBR is distillery for distillery wastewater? The reason, it distillery spent wash is high strength. UASB can handle high organic load, 5 to 15 kg COD per meter cube day or more. It produces methane. Low sludge production is there, lower energy requirement is there, compact and cost effective. So this is the reason, that's why we are using the UASBR technology, upflow anaerobic sludge blanket reactor for this one. Now this is the working principle, friends. Wastewater enters at the bottom and flow upward. In anaerobic condition, microorganisms degrade the organic matter and biomass is produced and rises. Gas, liquid and solids are separated in this upflow anaerobic sludge blanket. At the top we have a GLSS, gas liquid solid separator, GLSS. At the top in the diagram you can see here this one, gas liquid solid separator. So here it can be separated out and treated effluent flows out from the top. And generally when we talk about the gases, we know that generally majority two gases are there. methane and CO2. Methane percent is 65 to 70% and CO2 is around 30%. Now, sugar mill wastewater commonly contains sugar mill wastewater. If we talk about the sugar mill wastewater, friends, sugar mill wastewater consists generally biodegradable organic matter. As you can use your common sense, that's sorry, if we are talking about the sugar mill wastewater, that means excess quantity of sugar, and this sugar can be easily decomposed by the microorganism, so that means the BOD value comes out to be higher. So it will consist a high amount of BOD. Sugar losses, molasses, cane juice and washing operations introduce organic matter into the wastewater. So these all are the processes like sugar losses, molasses, cane juice and washing operations introduce organic matters into the wastewater, and as a result sugar mill effluent generally exhibit high COD and high amount of BOD. Most organic pollutants in sugar mill wastewater are readily biodegradable. Anaerobic and aerobic process can therefore effectively reduce its organic pollution load. Bagasse is the basically it is the fibrous residue after the sugarcane crushing. So after the sugarcane crushing, the fibrous material that left, generally it is termed as the bagasse. So bagasse is the fibrous remaining after the extraction of the juice from the sugarcane. It is commonly used as a boiler fuel and can serve as a renewable energy resource in the sugar factories. And one more point for you must know that press mud or filter cake is generated during the clarification of sugarcane juice. It contains organic matter and mineral constituents and may be utilized beneficially under suitable conditions. So just this is just informatory questions, like if question asked what is the bagasse, so the residue obtained after this one fibrous residue that after the sugarcane crushing. So the residue that is named as the bagasse. That's it. This is the key point that you have to remember. The major environmental effect of untreated sugar mill wastewater in the stream. Now friends, question is saying what are the major environmental effect of untreated sugar mill wastewater? If sugar mill wastewater is untreated, that means what is the what can be the environmental impact? We know that this wastewater consists high amount of BOD, and if we dispose it over any water body, what happens? The organic matter are going to be decomposed in that water body by the microorganism, and during the decomposition of organic matter, the high amount of consumption of oxygen is there. So when oxygen depletion is there in the water body, and if this oxygen depleted less than the 4 ppm, 4 milligram per liter, so the aquatic life cannot be survived. So for the survival of aquatic life, for the survival of fishes, and the oxygen must be present in the water body should be more than 4 milligram per liter. But if we dispose sugar mill wastewater directly, or that means untreatedly, so directly in the any water body, so the consumption of oxygen should be there. So oxygen depletion will be the problem, will be the basic problem, because we know the biological activity that microorganism in the form of oxygen, microorganism in the presence of oxygen going to decompose this biodegradable organic matter, or when it decomposes this biodegradable organic matter, it will consume the carbon from the biodegradable organic matter, because carbon is the source of energy, and the end product that forms is named as the biomass. And here we know in the biomass generally carbonate, nitrate, sulfate formation is there when aerobic decomposition is there, but when anaerobic decomposition is there, so the end product we obtain like acid, alcohol and gases. So acid, alcohol, gases generally will be there during anaerobic decomposition. A particularly important pre-treatment operations for dairy wastewater is. Now friend, question is saying particularly important pre-treatment operation for dairy wastewater. So if again question asks for dairy wastewater, what is the important pre-treatment? Again, dairy wastewater will also consist high amount of BOD, but also it will consist some oil and fat. And if we don't remove these oil particles, so what happens? The microorganism cannot be grow, because these oil particles, they prevent the growth of microorganism. So the decomposition of organic matter cannot be done by the microorganism. So we have to decompose chemically, but but we have designed our plant for the decomposition of organic matter biologically. So biologically decomposition cannot be there because microorganism cannot be grow in the presence of oil. So we have to remove this oil. For the removal of oil, we can use the skimming tank. We have a skimming tank like. So particularly treatment operation for dairy wastewater is the important is oil and fat removal. Oil and fat removal, we have to remove this oil. So dairy effluent often contains substantial fats and grease. Their removal by grease traps. Okay, as I told you that oil and grease particles are removed by providing the skimming tank, but sometimes in the absence, instead of providing the skimming tank, also we can use the grease traps. Oil and grease traps we can use that, or we can use the flotation method. We have a dissolved air flotation technique, so we can use that also methods that reduces the problem in downstream biological treatment. Generally in the skimming tank, this flotation or density separation technique is there. In the skimming tank, density separation technique is there because the oil particles are having lesser density than the water. So these oil particles coming to the surface, and from the surface it can be easily skimmed off. Milk and milk products contains fats, proteins, lactose, and these product losses and the equipment washing therefore create wastewater with high biodegradable organic contents. Now friends, next is high BOD in dairy effluent is mainly caused by high BOD. The question is saying that high BOD, what is the reason behind the high BOD in dairy effluent? Because due to the milk product losses. Even small losses of milk, whey and other products introduce significantly organic matter into the wastewater, and these compounds are readily biodegraded and produce high oxygen demand. So it is very simple question. Now, which treatment process is suitable for dairy effluent after the pre-treatment? We have done in pre-treatment, and what we have done in the pre-treatment, we have removed the oil particles and grease particles, right? But now in the wastewater, dairy wastewater, now you have organic particles. So you have to use the technology secondary treatment you have to do for the removal of. So this screening we cannot perform. Grit chamber chlorination, it is done for the removal of the microorganism. Screening and grit chamber we have discussed earlier. Now only option left, activated sludge. So we have activated sludge process. So activated sludge process can be used for the decomposition of organic particles. So after the pre-treatment, now we will do secondary treatment, and after the secondary treatment we do the tertiary treatment if required. So activated sludge efficiently removes biodegradable organic matter from the dairy wastewater. Adequate aerations, pH control and nutrient balance are important for stable operations. We will go for this activated sludge treatment process, and we know in the activated sludge treatment process, the SST, we have formed here SST for the settlement of the biomass, and this biomass is again being recirculated in the tank. We have discussed in the classes that the sludge from this SST is going to we are going to recirculate at the head of the aeration tank. The why we are saying aeration tank? Because continuously oxygen is being supplied by us in this tank. Dissolved air flotation in dairies is useful for removing this oil and grease particles. Dissolved air flotation is generally used for the removal of these particles. Black liquor is generally generated mainly during this black liquor basically generated during the chemical pulping. But during the chemical pulping, not leather tanning, not electroplating, not milk processing, just chemical pulping. Due to the chemical pulping, or you can say during this chemical pulping, black liquor is generated. So during chemical pulping, lignin and other woods components dissolved into the cooking liquor. The resulting concentrated dark liquor is known as the black liquor. Now if you look at this diagram, if you see this diagram friends, so here black liquor generation, so there are the wooden chips, this is the digester, chemical cooker like, and further pulp is being manufactured. So this, and along with that black liquor will be there. Composition of black liquor, that will consist lignin, hemicellulose, degraded carbohydrates like this. So black liquor concentrations, so it's weak black liquor from digester, concentrated black liquor 60 to 80% of solids. Evaporation in multiple effect evaporators, but no need to remember, just remember this point. During the manufacturing of chemical pulping, during the chemical pulping, this black liquor generated. Now what are the benefits of black liquor recovery? That is very important. Recovers energy, it is a renewable source. Recovers pulping chemical for reuse. Improve material energy efficiency, it reduces the operating costs. So this is the benefit of black liquor recovery. These are the benefit for the black recovery. A major source of color in pulp and paper wastewater. In paper and pulp wastewater, what is the major source of color? The major source of color is lignin and lignin derived compounds. So these substances are being used. So that's why this is the major source of color in the water. So as you discussed here that this black color, black liquor consists lignin 30 to 50%, right? Now biological treatment in paper and pulp effluent treatment plants primarily reduces. So this biological treatment is done for the removal of the organic substances. So it primarily remove the BOD. This dissolved salts are removed by tertiary treatment. If question asks about the tertiary treatment, then answer can be dissolved salts. If question asks about the preliminary treatment, so in the preliminary treatment we remove the grit, not grit only. In the preliminary treatment, screening process is there, grit chamber we have used. So grit removal, heavy suspended solids, oil and grease particles also we remove in the preliminary treatment. The operating principle of a skimming tank. This skimming tank, what is the operating principle? That density separation by flotation. As I told you right now, this skimming tank are used for the removal of oil and grease particles. If you don't remove these oil particles, they prevent the growth of the microorganism. So during the biological treatment, microorganism cannot be grow. So for the removal of those microorganisms, so for the removal of the organic matter, we want the excess amount of microorganism. So that's why we have to remove oil and grease particles. So skimming tank is being used. And in the skimming tank, what happens, we supply the air from the bottom of the tank. So here what happens, we supply the air from the bottom of the tank, and this tank consists of water in which oil particles are there. So when air will rise, so bubble formation is there, and this bubble having lesser density, so they will rise towards the surface. So when they rises towards the surface, they carry the oil particles through along with them, and the oil particles are moving towards the surface, and from the surface they can be easily skimmed off. Skimmed off means they can be easily removed from the water. You can say from the tank it can be skimmed off. A properly operating primary sedimentation tank typically removes what percentage of the total suspended solids? Now friends, when question asks about the total, primary sedimentation tank, so some important points, some key points are important for us to directly to be remembered, that efficiency of the primary sedimentation tank for the removal of suspended solids is 60%, or in the range you can say 50 to 70% is the range. But the answer is 60%. And efficiency for the primary sedimentation tank for the removal of the BOD, so the BOD, for the removal of the BOD, it is around the 35%. It is around the 35. We never design the primary sedimentation tank for the removal of the BOD, for the removal of the dissolved organic particle. We design our primary sedimentation tank for the removal of the organic suspended particle. But we know that when water enters in the PST and when it exits, it will take around 2.5 hours. So during this time, some amount of organic particles get decomposed by the action of microorganism. So some amount of BOD gets satisfied in the primary sedimentation tank. So we consider this values 35%, but we never designed our primary sedimentation tank for the removal of this dissolved organic particles. During anaerobic sludge digestion, methane is mainly produced during which stage? So friends, we know when we talk about the anaerobic sludge digestions, so here basically two types of microorganisms are there, like acid formers and methane formers. But when we talk about the stages of the decomposition during anaerobic decomposition, so 4 stages are there. First is hydrolysis, second is acidogenesis, third one is acetogenesis, and the last one is methanogenesis. When methanogenesis process is there, so in this methanogenesis, methane formation will be there, and ultimately methane formation is there, that means decomposition is completed. So during anaerobic sludge digestion, methane is mainly produced during this methanogenesis process, and that is formed by the methane formers that works in the narrow pH range of 6.5 to 7.5, friends, right? So just remember, these all stages are written in the sequence, very important points. Mesophilic anaerobic digestion is generally operated. Also we know that this anaerobic sludge digester we have, they works on a different temperature range. So if we keep the temperature range in the digester in between 20 to 40 degrees Celsius, So 20 to 40 degrees Celsius. So that type of digester we can say that is the mesophilic digester. So mesophilic anaerobic digester generally operated at the temperature range of 20 to 40 degrees Celsius. That means according to the option 30 to 38 degrees Celsius. Not take 20 to 25 because we have to take something higher values. So 20 to 40 degrees Celsius, it may be 25 to 40 degrees Celsius. So that's why we are taking this value. But also we have, if we elevate this temperature around 40 to 60 degrees Celsius. So we keep the temperature of the digester during the decomposition 40 to 60 degrees Celsius, then this digester is termed as the thermophilic digester. Now it is the mesophilic digester, but when you keep the temperature higher, then it will be termed as the thermophilic digester 40 to 60 degrees Celsius. If question asks about the thermophilic anaerobic digester, so answer will be D option 49 to 57 degrees Celsius. So remember this, mesophilic works on this range and thermophilic works on this range. And also we know when temperature is rises and the bond energy of the organic matter decrease, so microorganism can decompose organic matter easily, or in a given time the rate of decomposition comes out to be higher. The characteristics contaminants in refinery wastewater. Now we talk about the refinery wastewater. So from the refinery wastewater, what are the characteristic contaminants? So obviously we know, sir, when we talk about the refineries, so in the wastewater include some amounts of hydrocarbons, because all these are the hydrocarbons, and oil. So oil and hydrocarbons will be the characteristics contaminants. So dissolved air flotation in refinery wastewater is useful also for the removal of these oil particles, because oil particles are there. We have to use this dissolved air flotation technique. So this dissolved air flotation, DAF, this dissolved air flotation technique in refinery generally adopted. But the question is saying dissolved air flotation in refinery wastewater is useful for emulsified oil and suspended solids. Yes, emulsified oils and suspended solids. If some suspended solids are there, and also oil particles, but that are present in emulsification form. So if they are present in emulsification form, so along with this, during this dissolved air flotation, we also supply some amount of chlorine. Some amount of chlorine we also supply from the bottom. From the bottom we supply the air as well as some amount of chlorine. Also we have discussed this in our detail in our classes. We have discussed every points. So when air is being supplied from the bottom, and in the tank oil particles are present in the emulsified forms. So when oil particles are present in the emulsified form, so what happens, we want to agglomerate them, we want to combine these particles, but what happens, some enzymes are there which is not allowing, or you can say which prevent their agglomerations, which prevent their coagulations. So what happens, we have to agglomerate them, we have to coagulate them. So for their coagulation, what we have to do, we have to kill those enzymes which keeps these particles in the emulsification forms. So for killing of those enzymes, we have chlorine. So we supply some amount of chlorine that destroys such enzymes. When these enzymes are destroyed, now when air we supply from the bottom, so these bubbles rises, and these bubbles carry along with them these oil particles, and now these oil particles can be coagulated easily. So when these particles coagulated, higher efficiency will be there. So we get higher amount of efficiency. Also suspended solids, when air passes from the bottom, bubbles rises, and these bubbles also carry some amount of solids along with them. Lighter solids they carry along with them toward the surface. So dissolved air flotation in refinery wastewater is useful for emulsified oil and suspended solids. Sour water stripping primarily removes this sour water stripping. Now what happens, first of all, sour water consists dissolved hydrogen sulfide. Remember this point, this sour water consists dissolved hydrogen sulfide and ammonia generated during the refinery operations. So basically it usually requires specialized treatment such as sour water stripping. And stripping transfer volatile contaminants such as hydrogen sulfide and ammonia from water into a gas phase. Now listen carefully, stripping transfer volatile contaminants such as hydrogen sulfide and ammonia from water into a gas phase. So if we talk about the stripping, that means it transfers the volatile contaminants such as hydrogen sulfide and ammonia from water into a gaseous phase. That means the conversion of these substances are going to take place. The removed gases are then appropriately recovered or treated. So this sour water stripping primarily it will remove H2S and ammonia. So these all points we have discussed in the classes, friends. Most dissolved heavy metals can be removed. Now most dissolved heavy metals can be removed by hydroxide precipitations. Again, precipitations, in the form of precipitations, these metals are being removed. So most dissolved heavy metals can be removed by hydroxide precipitation. So adjusting pH converts many dissolved metals into the poorly soluble metal hydroxide. So just remember this point. If we want to remove the heavy metals, so they are removed in the form of precipitates, and the precipitates are formed of hydroxides. Hydroxide precipitations is going to take place. So this metal containing wastewater, this we have a wastewater, and it consists high amount of metal like chromium, nickel, copper, zinc. These are the metals which are present in the water. So pH adjustment, we have add some alkali, we have add like sodium hydroxide, calcium hydroxides. So these this substance that we have added, this substance going to react with these metals, and these metals are going to remove in the form of precipitates. Further, these precipitates are going to be removed from the water in the sedimentation tank, and from the sedimentation tank the particles are going to be settled, precipitates are going to be settled, right? So this is my point. The why hydroxide precipitation is more effective, because it converts dissolved metal into insoluble metal hydroxides, friends. So just remember the key points. This precipitation also we have discussed in earlier questions. We have discussed for the removal of phosphorus. Hexavalent chromium is generally converted to trivalent chromium before precipitation, because hexavalent chromium is toxic, carcinogenic. So we convert into chromium 3 positive. Cyanide containing wastewater should be segregated and specifically treated. Mixed with acidic waste, directly discharged, used as irrigation water, no. So these three options are wrong. It should be segregated and specifically treated, because again we know, because we are talking about the cyanide and it is highly toxic. So we have to segregate from the water and we have to treat it specifically. So cyanide is highly toxic and require controlled chemical destructions. Mixing cyanide waste with acids can release extremely hazardous hydrogen cyanide gas. Very important point. If you choose option number B, that mixed with acidic waste, so if you mix this cyanide containing wastewater with acidic waste, so what happens? It will release extremely hazardous hydrogen cyanide gas. Cyanide salts can form volatile hydrogen cyanide under acidic conditions. HCN is highly poisonous, making stream segregations and pH control critically safely measures. So remember, these are the key points, that hazardous hydrogen cyanide gas will be there when you mix with the acidic water. Ion exchange may be useful in electroplating wastewater. In electroplating wastewater that release high amount of metals, so in electroplating wastewater, ion exchange may be useful. Yes, but for which purpose? For the removal of this one, metal ion removal. Metal ion removal, ion exchange generally used for the removal of ions. Excess ammonia in receiving water can exert oxygen demand and be toxic to the aquatic organism. Increase oxygen permanently, remove the salts, remove all algae. No, for removal of algae, we can use the copper sulfate. We have a chemical that having some algaecidal properties. Excess ammonia present in the water, or you can say receiving water, excess ammonia is present, so it will exert high oxygen demand and will be toxic to the aquatic organism. Ammonia can be biologically oxidized to the nitrate, and we know when nitrogenous organic matter is present in the system, that will, if you are saying ammonia, excess ammonia is there, and ammonia can be present in the water in any forms. So nitrogenous organic matter is there, it will convert into ammonia, further it will convert into nitrite, NO2 negative, then it will convert into nitrate, and product is nitrate. So ammonia can be found in the water sample in the form of ammonia, nitrite or nitrate. The conversion of nitrogenous organic matter into the ammonia, it is named as the ammonification. The conversion of this nitrogenous organic matter into the nitrate, it is not termed as the nitrification. And when NO3 negative is there, nitrate is there, further this nitrate is converted as N2 gas, it is termed as the denitrification. So ammonification is there, nitrification is there, denitrification is there, right? So Remember this point. So when these organic, because this conversion is taking place like ammonia to nitrite and nitrite to nitrate, and this is aerobic decomposition, or you can say this reaction is going to take place in the presence of oxygen. So consumption of oxygen is going to take place, so that will be toxic to the aquatic organisms. Ammonia can be biologically oxidized to nitrate consuming oxygen. Unionized ammonia is also directly toxic to the fish at sufficiently high concentration, right? Biological conversion of ammonia to nitrate, as I discussed, as I told you right now, that it is named as the nitrifications. The conversion of ammonia to the nitrate, it is the nitrification process. And this denitrification will be this nitrification will be you can say this nitrification is the oxidation process, because this reaction takes place in the presence of oxygen. But when you talk about the denitrification, this is the reduction process. Phosphate rich wastewater can contribute to, if wastewater consists high amount of phosphate, that is going to increase, if we dispose that wastewater into any water body, so the high amount of algae growth you will observe in that water body, and that phenomena is known as the eutrophication. Because for the algae, the primary nutrient for the growth of algae, the primary nutrient is phosphorus. So phosphorus is the primary pollutant of any water body. Generally we talk about the lake. For the lake, primary pollutant is phosphorus. If phosphorus is present, so in a high quantity, so algae will be there, and this phenomena is named as the eutrophication. So for prevention of this eutrophication, we have to stop the supply of the nutrients. We have to remove the nutrients in our treatment plant. So tertiary treatment we have, so we can remove those nutrients in the treatment plant in the form of precipitates. We remove such phosphorus or any other substances. But for removal of algae, we have to add copper sulfate. We have also chlorine and lime solution. We can add also for the removal of algae. Phosphorus can commonly be removed chemically using. If we want to remove phosphorus chemically, then in the form of precipitates we can use, and the substances which we add in our sample in our water for the removal of phosphorus, that can be alum, or you can say aluminium, that can be alum, or iron salts or calcium salts, like we discussed in previous questions, like calcium hydroxide we have added, or also you can say iron salts or some aluminium salts, like alum we have, copperas we have, chlorinated copperas we have. So also these substances can remove the phosphorus in the form of precipitates. Pharmaceutical wastewater is often difficult to treat because it may contains, the pharmaceutical wastewater is often difficult. Why? Because it consists complex and refractory organic compounds. So these refractory organic compounds are there, so that's why these are often difficult to treat, right? So drug manufacturing uses solvents, intermediate and biologically active compounds. So some are poorly biodegradable or inhibitory to microorganisms, making treatment more complex. Major concern with antibiotics containing wastewater is, what is the major concern with antibiotics containing wastewater? Antibiotic containing wastewater, question is asking, what is the major concern with antibiotic containing wastewater? That means the wastewater which consists antibiotics. So they basically, what happens, residual antibiotics can exert selective pressure on environmental microorganisms. This may promote resistant organisms and resistance genes, making effective source control treatment important. So basically development and spread of antimicrobial resistance. So this microorganism cannot be removed, or that are going to create some disease. Now solvent rich pharmaceutical wastewater is preferably segregated for recovery or specialized treatment. Concentrated solvent streams may be toxic to biological treatment and may also have economic recovery value. Source segregation reduces the load on the main effluent treatment plants, right? So we have, friends, question number 40, low BOD to COD ratio in pharmaceutical effluent indicates. So what is the meaning of that? If BOD is, because we know that's a BOD indicates, or BOD is the indicator of the biodegradable organic matter, and COD is the indicator of total organic matter. So if for a wastewater BOD by COD ratio is lesser, it means COD value is higher, BOD value is lower. That means our sample consists inorganic matter in high quantity but biodegradable organic matter in lesser quantity. So if BOD by COD ratio is less, it means poor degradability, and pharmaceutical wastewater you will observe lower value of BOD by COD ratio. So that indicates that mostly organic matter is not biodegradable, they are the non-biodegradable, friends. Okay, so friends, these are the 40 questions that we have discussed, and mostly industrial effluents. Mostly we have discussed different industries questions like textile industries, tanneries industries, distilleries industries, sugarcane industries, pharmaceutical industries, like, right. So different industries, for the questions related to different industries we have discussed, right. So I hope every questions is should be every questions, if you have understood, and all the points are written, friends, in the PDF. Suppose if you have any doubt related to any questions, you can comment, and this PDF will be uploaded on the panel. The students, you can get this PDF from the panel, friends. Okay, so friends, the information that I gave you earlier, that if you want to know any query, if you have any query related to our module that we have launched earlier, so you can discuss with us. All the numbers are mentioned, contact numbers are mentioned, so you can directly contact us. Okay, thank you everyone.